Good morning, good afternoon to some of us joining our training today. Our training on our course on weather and climate services to energy sector in Central Asia. It's a very warm welcome from the side of the German Kazakh University. My name is Barbara Janusz Pawleta and I'm Vice Rector of the University, welcoming you right here. Уже наша краткая информация о том, что мы бы очень хотели вас пригласить сейчас к совместному фото. Поэтому, если можете, пожалуйста, включите свои камеры на этот момент, кому позволяет оборудование. Мы бы хотели вас увидеть. И такое историческое фото, когда нас 60 человек, но будет нас, наверное, больше. And here, without further ado, I would like to move to our program, to our session, and invite you to listen to our speakers who will be greeting us, who are co-organizers of this event. And we, as the German Kazakh University, are very pleased that we have such great partners to enable us for the first time for Central Asia to listen to such an important topic as a weather and climate services for energy sector in our region. So I will first will be speaking Professor Alberto Troccoli. He's the president of our university. Then we will listen to Alberto Troccoli, who is the chair founder of the World Energy and Meteorology Council. And then we'll listen to Roberta Boscolo from WMO, and first to Daniel Kuhl from the World Bank group, and to Roberta. But let's switch first to Mr. Rommel, and then Mr. Rommel, the floor is yours for the 3 minutes short welcome. Thank you.
Good morning or good afternoon, everybody. A warm welcome from our university to that great training, I would say. You should know that our university was established around about 20 years ago, and we just focused on transfer of European educational approaches regarding study programs from Europe to Kazakhstan. And that has changed dramatically because we had a learning curve during the last 20 years. We learned how should be the transformation and which challenges we face in Central Asia and Kazakhstan to have a sustainable development of this region. And so I'm really happy that we have that training program, because it's really in the focus of our university when we're talking about our topics in the upcoming years. Our focus will be more and more shifting towards sustainable developments, topics in research and education. We started with water management, and we are broadening our scope step by step. And of course, the energy system in Central Asia, particularly in Kazakhstan, is the key issue when you see the ongoing developments. The link between the climate system and the energy system has a dramatic importance for the upcoming years. In the traditional thinking, of course, the production of energy, it was just mining with very specific topics and understanding the challenges of mining. But now we have very different links if we are thinking about new energy systems. And I think against that background, the training program we have now is really a great adventure and challenge and opportunity to have a better understanding about the links between energy and climate. So I will stop right now, even if I would add some more remarks on that topic, and I will hand over the next speaker.
Thank you very much. Thank you. I'm pleased because Professor Rommel has just joined our university around half a year ago, and he was previously the president of HTV Saarbrücken University in Germany, and he was also working as a chief executive officer in the Telecommunication Research Center in Vienna, and was having also a different multilateral and different engagement throughout the world, I think. So we are happy to gain from his experience now at the German Kazakh University. Thank you for your warm welcome on behalf of us as co-organizers. And now I would like to give the floor to Alberto Troccoli, who is, I think now after the many months of preparations, a good friend. However, we never met before. Now is the digital era. Who is the co-founder of and managing director of the World Energy Meteorology Center, and also a visiting professor at the University of East Anglia. He has many years of experience, more than 20 years of experience in the field of meteorology and climate and energy, and also extensive list of scientific publications. If I would read the whole CV, which I do have here, it would take us long. So I think, Alberto, thank you so much for this opportunity to work together, and the floor is yours.
Thank you very much, Barbara. That's very kind of you to have this introduction for my short intervention here, and welcome everybody to this opportunity to learn more about weather and climate services, specifically for the energy sector in the area of Central Asia. And you will hear quite a few times from me during the course of the sessions, the 6 sections. But for now, I just want to say that I'm very pleased that we managed finally to have this course started. We started to discuss this many months ago, and we were really trying to have this training live, like in presence. Unfortunately, you know the situation, and so we're still here. But because this is, I understand, for the region as well, I know globally it's a very important topic. We hope that we can continue also in the future, and hopefully the next event similar to this, or a repeat or something like this, can happen in person. So I look forward to that opportunity when it comes. And just to put things into context, I also want to say that you know, this type of activities is something that we really promote at WEMC, the organizations I'm working with and for, and together with partners like WMO, and in this case also the World Bank and DKU. But we started with activities similar to this back more than 10 years ago. We started, for example, with the International Conference Energy Meteorology more than 10 years ago. The first one was in Australia, on the Gold Coast, and we've had 5 other international conferences after that, which have for the same reason as many events stalled in the last couple of years. But we look forward to starting them again, hopefully next year. And but we also run a lot of training events, and you can look at our website where we provide most of the lectures and material. And if you're interested, please get in touch. But thank you very much for joining this training course, and I leave the floor back to Barbara. Thank you.
Thank you, Alberto. Thank you to WEMC and all of your team for the great experience and learning from all your other events which you run globally. Now welcoming you to Central Asia, and I hope to continue this experience over the years to come. But it would certainly not be possible if we would not have such a big fans of the program and supporters in the organization of the World Bank, and now which is now represented by Daniel Kuhl. He is with us here, and he's the Senior Disaster Risk Management Specialist at the World Bank in the team for Europe and Central Asia, devoted to regional disaster risk management. So Daniel, thank you very much for coming and sharing your experience, also as a focal point to the World Meteorological Organizations, and having the regional background here for Central Asia. We are very pleased that you found it important to be here with us today and to support our training. Floor is yours, Daniel.
So thank you very much, Barbara. I'd like to start by, of course, welcoming everybody and really thanking you for joining this training course, which has been mentioned a few times as a first for Central Asia. I'm very much looking forward to also learning myself from all the different speakers and experts that we've been able to mobilize for this training course. Let me also thank all of the partners the DKU, WAMC, WMO. I think it's been a difficult process, as you mentioned, because of constraints that we've all been facing over the last 2 years, but we're finally here. And I think we have a great course on offer. So thank you so much for your engagement and your hard work in getting this set up and ready to go. As the task team leader or project manager of the World Bank's Central Asia Hydrometeorological Modernization Program, I'm happy to see a lot of old friends and acquaintances from the different hydrometeorological agencies in Central Asia. It's great to see you online, but equally exciting for me is to see the many different representatives from the energy sector also online, and to also be able to hear your side of the story as we move forward through the training course. This combination of having both the providers and, in this case, key energy users of weather and climate services is critical for Central Asia and for the long-term success in the energy transition. So this is a very exciting opportunity. And I can't wait again to see these connections being made with a common understanding of what's possible and what's needed. Finally, I'd just like to highlight that from the side of the World Bank, the financing we're providing to make this course possible comes from our Central Asia Water and Energy Program, or CAWEP, which is itself a partnership between the World Bank, the European Union, Switzerland, and the United Kingdom, with the aim to strengthen the enabling environment to promote energy and water security at the regional level and in, of course, the countries of Central Asia. For your information, this program, CAWEP, is structured along 3 pillars. One focuses on energy security, the other on water security, and then, of course, a third one that talks about energy and water linkages. And I think this course is, of course, critical to supporting our mission to increase the energy and water and climate linkages in the region for longer-term growth and sustainability. So with that, thank you so much. It's great to see you all, and I wish you a great course. Back to you, Barbara.
Thank you, Daniel. Thank you indeed for the support and for providing also the knowledge of the colleagues, facilitating, so to say, through your support. That's indeed a very important, I think, new development for Central Asia to talk about the weather and climate services for energy, to start building the other links than typically considered. But last but not least, of course, I'm extremely happy to also give the floor to Roberta Voscolo. She's with us here representing the World Meteorological Organization, and she is in the work stream for climate and energy. She's not only working in the international organizations globally responsible for the topic which we are covering, but first of all, she's also a person building through all her career bridges between science-based climate adaptation and mitigation and the political and social targets. I think being here, representing here the academia, we strongly feel about the very often lack of these linkages. So I think that Roberta is just the personalization of this, what we would like to be more. And she's also very much involved as an officer in the World Climate Research Program and many others. So again, I mean, it's too difficult to present such a interesting and good friends. But I think in your short introduction, we'll also learn more about the focus. Thank you, Roberta. Floor is yours. Roberta, your micro? Yeah.
Yes. Perfect. Can you hear me now? I would just want to say thank you very much, Barbara, for this introduction, and distinguished participant and student of this training course. I'm really honored to be given this stage to welcome you on behalf of the World Meteorological Organization, which is one of the supporting partners of this training event. And I would like to thank all the partners who played a role in making this event happening, and especially the CATS Hydromet, the World Energy and Meteorology Council, the Kazakh German University, and the World Bank. I am in first instance applauding you for deciding to start this learning journey, to learn about climate services and to apply it to the energy sector. It is a sector or any other sector that you are involved. Especially the nexus of climate and energy is at heart of the most defining environmental challenge of our present time. Energy is central to both achieving the Agenda 2030 for Sustainable Development and the Paris Agreement on Climate Change. Energy is key to poverty eradication, gender equality, food security, health, education, access to clean water, and many more developing indicators. But on the other hand, currently it is contributing to 72% of the total greenhouse gases emission, which is harming our planet and as a consequence causing sea level rise, changing in the hydrological cycle, increasing severe weather events, as we all learned from the IPCC recent report. So urgent actions are needed to transition to clean energy pathways and decarbonize the energy sector. And such phasing out of fossil fuel must be an integral part of the energy sector planning in the next decade. This means that rapid scaling up of renewable energy and increased annual rate of energy efficiency is important. Innovative solutions must be rooted in scientific knowledge and physical and socioeconomic context in order to achieve resilient energy system, economies, and societies. And this training will provide a framework for climate science for action, which is based on the ability to access and analyze climate information and data, to improve decision-making and increase the effectiveness of the climate action. And such training initiative is totally aligned with long-term direction and goals of WMO, of the World Meteorological Organization. And for this reason, although this is the first event in this region, I really hope it is not last. And actually, I hope this is like a seed that will grow and create a community of practice and a strong network of experts able to generate this tailored, science-based, innovative, and technology-driven solution for resilient and clean energy. The expertise that is represented here in this training course is unprecedented and truly impressive. And I hope you take full advantage from the knowledge offered and put in practice for achieving a sustainable world. I look forward to our learning journey together in these coming weeks. And thank you very much for your time. And thank you very much, Barbara, and over to you.
Thank you. I was so pleased to hear the long-term perspective, not only about the challenges related to climate change, but also to the possible solutions which we can also be part of. And Central Asia, indeed, I think needs this input, and also, all of the participants, I think they will be really appreciating this. By having all of that, all the statements and all of these contributions, I think that now it's a good time to just really once again say thank you so much to all of you, to the participants who are joining us, to the speakers who will be with us, and to give the floor to Alberto, who will be guiding us and through the program and showing us what are we going to learn and do within the 2 weeks ahead. Alberto, floor is yours.
Thank you very much, Barbara, for giving back the floor to me, and thank you also from me to Warad, Daniel, Roberta, and you, Barbara, for this splendid introduction, and of course the support again from World Bank and the World Meteorological Organization to this event, which couldn't have happened otherwise. So I just want to explain a bit how the program is going to be played out. And I put a link also on the chat where you can go to the webpage. You'll have seen it because if you registered, you probably went through that webpage, but you can find the updated program there. So I invite you also to go and get the program. Unfortunately, the PDF is only in English, but there is a double page, HTML double page with background, so Russian and English. So the program has the following objectives, so which are to create awareness and enhance knowledge about the design and application of weather and climate services for the energy sector in Central Asia. This is all based on, if you read the background, on what also Roberta was saying about the urgency of applying this information to improve the way in which energy systems operate and indeed are planned. So we want to try to build capacity on the application of weather and climate services towards this net zero energy transitions that are the targets for many countries around the world, and I understand also for Central Asian region, leveraging on international climate finance. We want to showcase how climate data, such as that provided by the TEAL tool of WEMC, will show you how that works, can be used to inform smart, clean energy transition in the context of policy and industry. And importantly, we want to foster a dialogue and partnership that hopefully will last for a long time between the hydrometeorological community and the energy sector in the region to address the major energy challenges in upcoming years. One, and probably the main underlying thread of the course is that we will provide this also training opportunity to achieve, and this is the goal of the course, to achieve a mini project proposal around weather and climate services. So as you'll have seen from the program, we have a component, we have several training sessions done in separate groups where we will discuss how we can put together a proposal, hopefully successful, that will bring together the communities from energy and climate and bring a successful service for weather, to use weather and climate. So that could be using forecasting for wind power, for example, or planning a solar power station, or understanding how much water there could be in 30, 40 years' time to run the hydropower turbines. All these things will be discussed in some level of detail over the next 6 sessions. So as you know, we are running on alternate days, Monday, Wednesday, Friday this week, and again next week. So it's 6 sessions, as I said, from 9 UTC for 3.5 hours hence. So next slide, please. I've already said about the next slide, how this, but just to emphasize also that we have a story we're following, of course. So we start with some basic around weather and climate services, why they are important. First, looking at the energy aspect, what is the demand from the energy sector around these services, and then we'll discuss a little bit the basics of what they are, and we'll try also each day we'll have a panel session where we go into a bit of a discussion and interaction with all of you, and you're welcome to ask questions. In fact, you can ask questions anytime. You can type questions on the chat. And actually, I would encourage all of you to keep the camera on, because although we are at distance, I think it's still nice to see each other. It's not very nice actually to speak to a name printed on the screen. It's much nicer to see someone, a face. So if I understand some people may have difficulties with the cameras or the speed of the internet, but if at all possible, please use the camera at all times. However, the microphone should be on mute unless you are requested to turn it on to speak. So thank you for that. Please remember throughout the course, camera on. That'd be very, very appreciated. Next slide, and I'm nearly done. So I just want to show you, this is on the program, on the PDF, but just to remind you about today, we have a couple of lectures. One is given by my dear colleague, Laurent Debout. Unfortunately, he had to change his plan at the last minute, but he recorded a lecture, and I can try to answer some of the questions he had from his lecture, but he will be with us on session 5, again, on the panel session, and we can go back to some of the points he's making here. A very interesting introduction to the energy scene. And then we'll have a break also, and a panel, so other 2 lectures, apologies, on the energy sector in Central Asia by our colleagues from UNICE and ESCAP, and I also actually want to acknowledge the important contributions of these 2 organizations, UNICE and UN ESCAP, to the training course, because they have greatly contributed together also with the Kazakh Hydrometeorological Service to the program of this event, and indeed to contributing as speakers. So we look forward to their contribution. And then finally for today, we have a panel with 4 very important speakers, and we'll get there in due time. So before we go to the next session, I want to briefly introduce the chair of the next session. So it's someone with who we worked for many months now to bring together this program. So it's a great pleasure to introduce you to Alexei Kobzev, which is a project manager for renewable energy and climate change at the Deutsche Kazakh University, DKU. He has more than 15 years of experience in projects of UNDP, Uzbekistan, UNDP, RBC, UNESCO, UN ESCAP, etc., on developing concepts and strategies for environmental protection and sustainable development, as well as big data and management. He gained experience in Central Asia regional economic cooperation while working in the program Climate Change and Sustainable Energy. He has also built up expertise in the creation of management of the knowledge and project management unit. DKU is working on the development of education in the field of renewable energy in Kazakhstan and the development of cooperation in this area in Central Asia. A new master's degree, Strategic Management of Renewable Energy and Energy Efficiency, was developed and launched this year. And he has also implemented the annual project Renewable Energy Trip from 2018 to 2021 for students from Kazakhstani and Central Asian University and young professionals. So as you can see, quite an important curriculum, and also something that is very closely aligned with this course. And we look forward also to future collaborations on the training, like we said. But without further ado, I hand over to Alexei, who will chair the next session. Thank you. Over to you, Alexei.
Thank you very much, Alberto, and I really glad to see all of you here, and I hope and I'm sure that we will give all of your ideas. We will give this information about your ideas, about your question, and we will give a lot of information to that you have your interest will realize. And now, thank you very much, Alberto. And of course, I would like also to go for the first topic of the course. Now it's Laurent Debout that alongside with Alberto will explain what weather and climate services are, and also to demonstrate how this is available for energy sector. Laurent is the lead scientist in weather and climate with French transmission system operator. working on long-term power system evolution and resilience to climate change and short-term forecast. He is also co-founder and non-executive director in the World Energy and Meteorology Council. He holds also engineering degree and marine environment and PhD in physical oceanography. He has also skills and experience in climate system modeling, weather and climate forecast, power system management, and climate services design and development. His activities are dedicated to improving the effective integration of high-quality weather and climate information into energy sector planning, risk management, and operational activities to better manage power system on all time scales. For the first hour presentation, we are going to play the video, a recording of his talk, because Laurent Dubois cannot join us today for the session. However, he will be with us for session 5 as a panelist, where we will have the opportunity to meet him and ask questions. And before also we start the video, I would like also to mention this also Alberto, who is the second presenter, and to mention his great input in this development and realization this training. Thank you. Please.
Good morning or good afternoon, everyone. It's my pleasure to be here today with you in this training course. It's my pleasure to be here, but I'm not really here because I'm this presentation is recorded, and I would like to apologize for that, but I had other constraints. I hope it will make sense anyway, and in case you can always contact me afterwards in case you would like clarification that would not be answered by the people online today. So I will present you a very brief and global overview of the energy sector. The learning objectives are to give you key figures about the energy sector in general and the power sector in particular, and also to highlight some recent trends and paths towards sustainability. And I will also say a few words about why climate services are important for the energy sector, according to my experience. This presentation is based roughly on a few presentations, a few documentations, sorry, that come from 3 main organizations that publish regular reports, either every year or on a less frequent basis, but they do publish very interesting reports, which are very comprehensive in general. So the first source is the International Energy Agency with its World Energy Outlook, which is an annual publication. Then we have the World Energy Council publications, especially the World Energy Tridemna Index, which I will explain in a few minutes, and the World Energy Issues Monitor. And last but not least, we have the REN21 network, which publishes every year its Renewables Global Status Report on the one side, and from time to time, they also publish regional analysis. And especially in 2017, they published one about Europe and Central Asia. And this one will be updated this year, I think, if I not misleading what they said on their website. So, as you may know, we have a list of serious problems as humans on the Earth. So we have issues with the loss of biodiversity, we have geopolitical issues, peace issues, and so on. But we are in a weather and climate services training course, so I will talk about weather and climate-related problems. So our main threat is climate change, which I think now is absolutely evident for almost everyone that climate change is caused by anthropogenic activities. And so in this context, the energy sector, which is responsible for a significant share of the greenhouse gases emissions, needs to make a very important transformation. I would like to introduce the World Energy and Meteorology Council Energy Trilemma, which is a way to measure progress, and it's based on 3 key indicators. So the first one is energy security, and this refers to the nation's capacity to meet current and future energy demand reliability for its people. The second indicator is the energy equity, which allows to assess countries' ability to provide universal access to affordable, fairly priced and abundant energy for domestic and commercial use. And the last one is the environmental sustainability, which represents the transition of a country's energy system towards mitigating and avoiding potential environmental harm and climate change impacts. So these indicators have been set up, I think, more or less 10 years ago now, and they are updated every year based on the progress made by each country. The World Energy Issues Monitor also provides an interesting view as it gives an overview of energy leaders' agenda and energy leaders' concerns in our world. So it's updated every year as well under the form of an extensive survey made towards policymakers, energy business practitioners, and so on. Basically, it presents the results with 2 dimensions. The first one on the x-axis is the impact, the importance of the impact, and the one on the y-axis relates to uncertainty. So they consider a large number of aspects, like, for instance, energy efficiency, digitalizations, economic growth, commodity prices, climate change management, of course, renewable energies, and so on. Sorry. And so based on the survey's responses, they can put all these aspects on this matrix, so linking the impacts and the uncertainty. And what you can see here is that there are large and numerous uncertainties, especially this year. It was less pronounced last year. And in practice, when you want to consider the energy sector and the topics that the sector needs to take into account and needs to tackle to plan future energy systems, then you have a lot of uncertainties coming from many different aspects. And so this makes the energy sector a very complex environment with interconnected challenges. Let's have just a quick focus on Europe and Asia, which I think cover most of the countries where you are from in the training course. So basically, again, these 2 dimensions can be summarized with the critical uncertainties across regions, and this is what WEC call the what is keeping energy leaders awake at night. Sorry. So from highest to lowest scores. And the second dimension is the action priorities across regions. So it's the what is keeping energy leaders busy at work. So it's linked to the previous impact dimension on the previous graph. And so you can see that there are local differences from one area to the other, but there are also many things in common. For instance, for Europe and Asia, commodity prices come first, especially with the recent energy crisis linked to the geopolitical situation with Russia and Ukraine and so on. And geopolitics also, of course, comes very top in the list. But climate change management is also very important in both regions. And regarding the action priorities across regions, so renewable energies development and integration into energy system together with digitalization are already on the top of the agenda, and that's very important. And so, as we can see, there are local differences, but many things in common, and also similar priorities from one region to another. And then it makes that collaboration can only be positive in this regard. Now, let's have a look now at renewables. So this is a figure from the REN21 Global Status Report, which shows from 2014 to 2020, the annual additions of renewable power capacity by technology and the total over the period. What you can see is that, sorry, every renewable energy has been increasing over the period, even if there was a slight decrease in wind during 2016 to 2018, but now it's rising again. Biopower has not the best place here, and hydropower neither. And in practice, what is the most important is solar PV, which is really developing very, very fast all over the world. There are differences from country to country, but when you look, for instance, at the development of solar PV in Europe, it has been following an exponential growth. So today, we end up having 256 gigawatts added in 2020, which is really, really important. And so solar PV is the fastest growing renewable energy source. This is driven mainly by decreasing costs. You can see the evolution from 2010 to 2020 of the levelized cost of electricity, which is basically the generation cost for one specific source at utility scale. Sorry for that. And so we have the figures for solar photovoltaic, solar concentrating thermal power, offshore and offshore wind power. We can see that the cheapest one used to be wind power, but now it appears that solar photovoltaics are really close to onshore wind power. There's only a slight difference, and the largest decrease was in solar photovoltaics. Sorry, I'm not going in the right direction. Okay. More specifically in Central Asia, I won't go into the details, but you have more figures and explanations in the REN21 report for Uni CE, where you can see that the trend varies from one country to another. So it's the share of renewable energy in total final energy consumption in a selection of countries between 1990 and 2014. Sorry, there are not more recent figures, but as I said, this report should be updated this year, so you will be able to find data at least until 2019 or 2020, I guess. But what we can see overall is that apart from a few decreases, which I can't explain because I don't know the region enough, globally there's an upward trend in many countries regarding the share of renewables in the total energy consumption. However, fossil fuels still dominate the total final energy consumption. We can see here the evolution between 2009 and 2019 based on the REN21 report. So modern renewables have grown from 8.7% to 11.2%. So there's a little increase there, but basically fossil fuels are still the same share, and it's not decreasing significantly. In practice, for electricity, here you can see the global electricity production by source and share of renewables on the right of the figure. And basically what you can see is that the increase in renewables, barely covers consumption increase. So the contribution of renewables has been increasing very significantly over the last 10 years. But in practice, it only covered the increase in energy consumption, in electricity consumption in that case. So now the question is, where should the efforts go? If we split the total final energy consumption by energy use. So the main uses are the thermal uses for cooking, heating, and so on. The transport uses for cars, trucks, planes, and whatever you want. And then the power generation. You can see that power generation accounts only for 17% of the total final energy consumption. But the rest is based mainly on fossil fuels, so thermal and transport. And so the efforts should really go to decarbonizing the energy used in thermal production and transports, which is more difficult than electrification, than the decarbonizing the electricity sector. And so this is the real challenge. However, it remains that the power sector is not green in all countries. Many of them still use coal and gas and so on. And so there are efforts that can be done in the power sector as well. But in terms of technical aspects, it's much easier for the power sector. So to decarbonize the power sector than to decarbonize the transport sector and the thermal sector. Because, for instance, the heating of buildings has a much longer, how could I say that, turnover time, maybe. So it takes more time to renew buildings, to change their heating equipments and so on. So where are we going and where are we on the objectives? So this is from the IEA World Energy Outlook 2021, so published at the end of last year. And it presents the global emissions in gigatons of CO2 equivalent from 2000 to 2050. So for until 2020, it's actual estimations, and then it's pledges or scenarios up to 2050. Of course, you can see in 2020 the decrease in global emissions due to the COVID crisis. I think it was estimated to roughly 6 gigatons of CO2. And then the red line is the pre-Paris baseline. The stated policies after the Paris Agreement should have been on the no, it's the blue line, sorry. Yeah, the stated policies. And the Glasgow pledges more recently at the COP26 conference are even lower and should be reaching less than 25 gigawatts of carbon, of CO2 equivalent by 2050. So here we are. And if we want to reach the objectives of net zero emissions by 2050, you can see that a lot needs to be done still, because despite those positive signs that we could observe in the last years, today's pledges close less than 20% of the gap of the net zero by 2050 scenario. Countries with net zero pledges and countries without each account for about half of the remaining ambition gap. So are we on track? Not really, I would say. So here you have the conclusions of the World Energy Outlook 2021. I'll take the time to read them because I think it's interesting. So the transition to a sustainable energy system is the solution to the turbulence that we are seeing in gas, coal, and electricity markets today, and they are not the cause. That's important to remind. A laser-like focus on clean electrification, energy efficiency, methane abatement, and innovation can close the near-term gap with a 1.5-degree future. Cost-effective solutions are available, and every country needs to step up. This refers to the fact that, for instance, we really know how to decarbonize the power sector. There are some digitalization solutions to the integration of renewables in power systems. So there are technical solutions which exist, which are mature, and which can be put forward to meet the challenge we have But of course, the longer today's mismatch in energy investments persists, the greater the risk of energy security and price volatility. A massive policy-driven surge in clean energy transition is the way forward. We have the solutions, but the political decisions are too slow and not strong enough to meet the targets. A new global energy economy is emerging, one that will be more electrified, more efficient, digitalized and clean, and that will offer enormous potential for growth and employment. This has been estimated by different agencies, including IEA, but also RAN21 and others. And really the green path towards energy is really an opportunity for growth and employment. Of course, governments have unrivaled capacity to transform the energy sector. A wave of investments in a net zero future must be driven by an unmistakable signal from Glasgow. So that was before the Glasgow conference, the COP26. I'm not personally sure that the expectations were met in Glasgow, but I think some pledges were taken, and some actions will follow, hopefully. Just to comment on the fact that government have a very strong role to play. There have been some estimations in several countries, including France, and I know the figures for France. And it was estimated that the necessary efforts to make toward net zero emission by 2050 can be accounted for by individuals themselves. For around 25% of the effort that is needed, which means that the remaining 75% needs to be done and promoted by the government, by local authorities, by businesses, and so on. So every one of us can do something, but the collectivity, the collective aspect, the national aspect is also extremely important. So from these conclusions from the IEA, I would say that energy efficiency, electrification, and digitalization will be key. And in that landscape, renewables have a crucial role to play. And of course, weather and climate services can help a lot. And so what would be this role for climate services, and how can it happen? So basically, energy systems will integrate more and more renewable energies, especially wind, solar, and hydropower. By doing this, the dependence of energy systems on weather and climate will increase. It will be really much stronger than it is today. And so weather and climate services are becoming more and more important. I would even say that weather and climate services will be a key for the right and efficient integration of renewable energies into power systems. To ensure the efficiency and the success of climate services development, I think there are three essential components that need to be taken into account. I will start by data. Data is really king, as this nice picture shows, because if you want to set up wind generation forecast or solar generation forecast or whatever you want, you need data first to train your models, to evaluate their performances, to monitor the outputs and so on. So really, data is extremely important. Today, some progress has been made in the collection, quality checking, and sharing of energy data, but we are really, really far from the ideal targets. And from that point of view, we could say that the weather and climate community has a very strong experience in data sharing under the auspices of the World Meteorological Organization, because we know that we can't do any weather forecast if we don't share the data worldwide in a transparency, well-documented and quality controlled approach. This is extremely important, and only by providing transparent, well-documented and quality data from the energy sector, from the energy point of view, we will be able to increase the quality of models and to ensure that what weather and climate services can develop is really, really efficient. The second aspect is the fact that if you want to develop a service, whatever the domain you are working in, I think the most important thing is to know your users, to talk with them, to understand their problems, to understand the context in which they are working, so as to be able to develop the best solution that is really tailored to their needs. And for that, I mean that it used to be that maybe 10, 15 years ago, when as a user you were going to National Med Service asking for some information, the first response from the Med Service was to try to sell you what they had on their shelves, what was already available, but not really taking into account the exact needs of the end user. I think this has changed a lot, but there are still some way to do in that direction. The recent development of climate services, especially, has allowed to put forward some obvious approaches that help to better act in this way. And I think it's really critical to keep this in mind. Know your users, understand them, and try to put yourself in their place in practice. And so the last key ingredient, I think, is, of course, it's linked to the previous one, but it's really about establishing partnerships and collaboration. Climate services, unlike any service, cannot be developed of the reality, I would say. It needs to be done in really in collaboration with the user of the service in the end. I will just give you an example of some climate applications in the energy sector. So I'm working for RTE, which is the French transmission system operator. That's to say the operator of the high voltage power network, which in Europe is interconnected with all the countries, those in blue on the map. And so we recently published a significant study looking at energy pathways to 2050 for France, in which we studied 6 different scenarios for the evolution of our generation mix and our power system in general. And so, as you can see on this figure, we took into consideration climate change and climate variability by using climate data related to the years 2000s and also to the years 2050 for 2 RCP scenarios. But you can see also that this information is only a small part of all the information that feeds our power system model. And so the message I would like to bring here is that climate data is important, is not enough considered into power system studies. It's developing, it has been developing in the last years, but I think there is still a lot to do. However, climate science is not the goal key to power systems modeling. And if you are working the climate area for the energy sector, I would say that, you should stay modest and don't think you'll change the world alone. Climate services are an important component of a complex chain, but they are not the solution by themselves. So you need to interact with all the other components of power modeling and energy modeling in general. You will bring important value, but don't think you will solve all the problems yourself. So let me come to my few conclusions. So I hope you understood from this presentation that the energy transition towards low emission scenarios, low emission generation mixes, increases and will increase further energy systems dependence on weather and climate. So variability, climate change, extremes, and so on. Energy planning, so long-term planning and shorter term operations require information about weather and climate. This information needs to be authoritative in the sense that power systems operators and actors have to complain to regulations to rules at the local, national, and continental level in general. And so the information must be authoritative in that sense. So it must be more or less state-of-the-art, transparent, and validated by the scientific community, I would say. And so in that path, I really think that climate services are a key component, and the user-provider collaboration is really essential to deliver the final products. And those final products should be user-driven, so based on the user needs, but science-based, which means at the state-of-the-art and validated from the scientific point of view, in order to be efficient and efficiently integrated into energy system planning, operations, and all activities. With that, I would like to thank you. Unfortunately, as I'm not online, I won't be able to take questions, but I guess that the other speakers can answer most of them, and I would be happy to be contacted by email in case you have further questions after the session. Thank you very much, and have a nice training course.
Thank you very much. And now, of course, I would like to give the floor. It's Alberto Troccoli, and he was a little bit early introduced by Barbara. But nevertheless, I would like to mention that Alberto Troccoli now is a co-founder and managing director of World Energy Meteorological Council and visiting professor, University of East Anglia. Alberto also gives us some interesting information about this climate energy services and a little bit about the World Energy Meteorological Council. Dear Alberto, please, the floor is yours.
Thank you very much, Alexei. And I am going to go a little bit deeper, but still at a pretty high level in the explanation of what weather and climate services are. We heard quite a bit about the words from Laurent, and indeed this talk was a very important and interesting one to set the scene for the whole training. I just want, before I start, I just want to remind everybody that, like I said before, we have 6 sessions over 2 weeks. And we also said in the registration that we were going to, or we are going to provide a certificate of participation to people who are attending at least 5 out of 6 sessions. So we don't give certificates to everybody. We want to be sure that people participate, particularly not only, but importantly also during the working groups starting at the next sessions. However, because it's very difficult to see whether people are actually attending, I just want to invite you once more to switch on your camera and keep it on for the duration of the course, please. I think that's very important, and it's a gesture also of kindness to all people that are giving their time here to present, and all the preparation that has gone on into this training. The lectures are being recorded, and so you will be able to see them also after the training at some point. I'm not sure exactly how many days after the training course, so it won't be straight away. So it's better to be following now and learn what we're saying, and also ask questions. That's the important part of being here with us. You can ask questions. But yeah, as I said, it'd be good also to see you. Right, so I start my lecture, hopefully short, but it's going to take about 20-25 minutes. And I want to touch particularly on what the weather and climate services are. So I'm going to give you a very high level view and definition of what they are, and then a simple illustration. So this is just to get us started. I won't provide any particular solution here, but I just want you to get acquainted with the topic. So if we go to the next one, please. I just wanted, in addition to what Laurent was saying about the importance of having the weather and climate services for the energy industry, I think one kind of motivational slide and indeed vision for what could happen in maybe 40, 50, 60 years or more around the globe is this interconnection between all countries around the world. So this is a vision put forward by GEICO, the Global Energy Interconnector organization in China, which builds on some regional projects like Desertec, that was still is on paper a project between North Africa and Europe to transfer energy there. There was also a Desertec Australia to link Australia with South Asia. But this one puts goes up 2, 3, 4 notches. So it's really, really ambitious. And so you can see that if we are to achieve this, we need to know how weather and climate is going to affect energy systems, particularly because most of the systems that would generate electricity for this system would likely be renewables, like Laurent showed that there's a large increase in solar power, for example, but wind is the same. So it's expected that although we are still at about 20% of renewables overall, this will continue to increase over the next few decades, according to also to the goals of Paris Agreement and then Glasgow. So next slide, please. We now look at how the energy and meteorology interact with each other. We basically see that the energy and meteorology are very closely connected in many, many ways. So if we look at what happens in the past, we have a lot of observations from satellite, from reanalysis, different climate realizations of the weather of the geophysical system. And that is closely connected to many of the things that can be done in the energy sector. For example, we can use it to assess severe events in order to plan new systems. And then looking forward in the future, in terms of forecasts, we have various ways in which we can forecast the future, starting from a few seconds, for example, using sky cameras to look at the movement of clouds and how the sun goes through the clouds in order to supply solar power forecast to avoid big drops in solar power, or not to avoid, but mitigate the large changes in solar power. And if we look farther forward, we can see that we can produce predictions for hurricanes, for example, that relate to disruptions to operations at sea, or longer time scales with the interannual variability and El Nino. So this is a global climate phenomenon that can affect demand patterns all over the globe. And then on even longer time scales, we look at climate projections that can be used, for example, to assess new projects, how the wind or solar power, hydropower can change in the next 30, 40, 50 years or longer. So in the next slide, we see some more specific example of how the energy and meteorology interact on an operational level and on management level. So weather forecast and monthly forecast, so weeks ahead, are normally used for operations and maintenance of energy systems, whereas seasonal climate forecast or climate projections are used for respectively management and investment and planning of energy systems. Incidentally, this is not so only specific to energy. This kind of information applies to other sectors like water, agriculture, health. But for energy, there's this connection is being established over many decades, and there's a lot of experience around the world on how to use many of these products from weather and climate, although many of them are still being developed. Next slide, please. So we now go and look at a bit more specifically at what the weather and climate services are. So these are services that rely on the production and delivery of relevant, credible, and of course, valuable climate information. And so this is what is normally stated as a service for weather and climate, but you could also ask yourself what would be otherwise if you don't provide credible, valuable, and relevant information. But I think it's important to state it just so it's there and we know what the target is. And to have a more specific definition of a service, I would say that we can call it a set of actions aimed at helping beneficiaries make the best use of tailored information so as to improve their business. So in other words, weather and climate services are meant to solve real-life problems by translating the best, latest science into practical solutions. And the key distinction is in the services is its purpose. So it's whether the climate service is done for public good or for private good. This, I won't have time to go into a lot of this distinction, but if you bear in mind the fact that the way in which we approach services, weather and climate services, is different for when we look at public or private, then it can help you also understand some of what we say next. So in the next slide, I go a bit into the specific of what could be the characteristics of a weather and climate service. So we've seen that this service is not unique. So it's basically, there are other types of services. It's not just weather or climate. What is distinctive is the word service more than weather and climate. And if we do that, we can relate this to other services like financial, medical, or even a car service. So these services naturally differ from each other in terms of their specific purpose, of course, but we can identify common features. So here I give 4 features that I identified in a publication that is freely available. I referenced before, and let me know if you're interested. So the services are characterized by their maturity. So how long have they been around? That's important because obviously if they are been around for long, it means that they are more reliable and more credible. Then the second one is their tangibility. Is it something that we can easily relate to? So it's something that we can touch, or like a car service, or it's more abstract, like a financial service. And the level of risk, how reliable and or accurate is the output product? This is, I think, understood. And then the trustworthiness or credibility. How much do we trust the service provider? So in the next slide, it's just an example. It's not something that is based on any particular statistics, but it's just kind of guess. I think it's pretty close, but it just gives you an idea of 3 levels of the characteristics for each service. So there is maturity, tangibility, level of risk, and trustworthiness. And so with the qualitative level for comparison between the 5 different types of service are given with H, M, and L. In the red, I want to draw your attention to weather and services and climate services in particular, and particularly for climate services, so you understand why there is quite a bit of red here. The reason being that, for example, the L, we have a low maturity for climate services, whereas weather services are pretty high. So low maturity is probably around 10 years or less. High maturity in this case is 30, 40 years. So that gives a bit of indication of how long they've been around. And then the tangibility also of this information is pretty low because it's not unlike a car service, you cannot touch it, or a medical service. Here is pretty low. Level of risk also is high because of the uncertainty that comes with particularly the climate projections. So there is still quite a bit of range, as well as like seasonal forecasts for predictions 2 or 3 months ahead. Less so it's medium for weather forecast, because although there's still some uncertainty, they are pretty much established, as I said, and also they've managed to reduce the uncertainty here. And this is my guess of trustworthiness based on the fact that scientists for weather and climate services are in normally a pretty trustworthy category overall in society. Next slide, please. I want to show you that basically the weather and climate services need, particularly in the case of private sector, and that's what also I was referring mainly before, it's quite mature. And in the case of weather services, there's actually quite important investments, very high investments in the last year or so. You can see figures like 245 million for a company in the US to invest in satellite data analytics solutions. So it's a huge amount of money, and then you see others with 77 million and so on. So just to give you an idea of how much private investment is going into the services. It's not just for energy, of course, but energy is normally one of the main areas where this private services are focusing on. So next slide. So we now look at an example, a simple example. I mean, it's not so simple, but I'll keep it simple just for illustration. And it's coming from a project that terminated not long ago, and I was leading a European project called Secli Firm. And this one case is the one that actually started the whole proposal and project, and which is a large heat wave that hit Southern Europe in 2015, and in July 2015 for the to be precise. And that led to a big increase in electricity prices in Italy, particularly driven by the surge in use of air conditioning in this case. So that also led to a strong hydropower production to compensate for the request and demand of all this power, and then led also to consumption of water reservoirs. So the reservoirs were depleted to a great extent. So next slide, please. So what we did with Secli Firm, we tried to see if we could predict this kind of event with a few months in advance under what is called seasonal forecast, which I mentioned before. This is one of the products. Next slide, please. This is one of the products that is used in weather and climate services. Seasonal forecast technically sits under climate services rather than weather services, because it's more like a scenario type of forecast, but it's actually starting with the same premises of weather forecast. We will learn more about that in the next one of the next lectures. But for now, I just wanted to show you some of the results. And these are that with the current systems, and there are several systems that are used to predict seasonal forecast, we can have a fairly good idea of the trend. So whether the temperature in this case was going up or not. And what the models tell us is that the temperature was predicted to increase as it actually happened, but at the moment they are not showing such a strong signal as it happened in reality. That's not unexpected, and it's actually good overall that the signal is going in the right direction. That's an important first step in using these models, and an important step to also give confidence to users. In this case, it was the Enel, the power company, the main power company in Italy, and actually worldwide. They have activities and in several other countries around the world. And so that this was the first step in trying to embed this seasonal forecast in the management of the decisions for few months ahead for problems like the one we've seen of the steep increases in electricity. Next slide, please. So that component I described actually involved several other steps on the way, and includes also visualization of the information. But before that, we had to spend quite a lot of time to understand how the decision-making was done within NL in order to find out how we could incorporate the seasonal forecast in the decision-making specific to their use. So on the right-hand side, you can see some of the steps we followed to understand how we could incorporate the seasonal forecast. Next slide, please. So we then ended up with a visualization of the information. So the visualization tool called Teal on the right-hand side. On the left-hand side, you see another example. This is from another case study, which I put here because I want to show you that there are several ways in which we can deliver weather and climate services. It's not just with visual interfaces, but we found that visual interfaces are much easier to understand and play with and interact, and to some extent they can also a bit more attractive and conducive to interaction. So we should keep an open mind in the way we deliver weather and climate services, but we need also to be aware of the options that we have around, and there are several, particularly because especially in Europe, the European Union has invested a lot of money in recent years to develop new services, new ways to display the information and interact with users. Next slide, please. So the interaction with user, which I just mentioned, is key to producing valuable and something that can be therefore used in the long run service. And this is done through what is called co-production. So co-production is sometimes a bit overused as a term, and what it means is that there is a close engagement with stakeholders, so people who are interested in using weather and climate services for energy or other needs, and they are keen in the dialogue for transferring knowledge, and particularly instilling confidence in weather and climate services. Because like I said before, it's intrinsic in the product of climate, that particularly that there is a lot of uncertainty. And so when people hear about uncertainty in the climate, they tend to turn off their ears and not pay attention. However, there are, as we know, uncertainty is dealt with in all kinds of decisions, not just weather and climate. So it's important to understand what they are, what the limitations are, but ultimately this is important information as we are finding out so climate services and the projections and seasonal forecasts is something that users want to actually use. And so we need to simplify the language in which we present them in order to make them more approachable, but at the same time demonstrate that they are based on robust scientific knowledge. So one term that I've come up with is to call this co-production, which involves, the co-production involves actually 3 steps. There is a co-design, co-development, and co-evaluation, and so you may it may help to remember the steps by using the co approach or co-production, which involves the 3, as I said. But ultimately, this co-production, as I am quite a practical person, and as I said, co-production is a bit overly used. This co-production is nothing else than some good communication between people producing the weather and climate information, so the forecast data and so on, and the people using it. So there needs to be a continuous dialogue between the two, understanding at every step whether something that is being developed is useful. If it's not useful, you go back to the board and start the planning again, start from the co-design. Because one of the things that normally happens as scientists from the weather and climate community is that we go off and think and produce something that we think is going to be very useful by someone in the energy sector, and then we find out that it's either incomprehensible or off target or both or even more. And so that's why it's important to start the dialogue as soon as possible and keep it going. So next slide. So this gives you that you find several of representations of ways in which the co-production or user engagement works. This is from a publication that we are producing with the World Meteorological Organizations and led by the World Energy Meteorology Council. And it just, as you can see here, it goes from understanding the needs and solutions, like I said, to start a discussion with users at early stage, and then you start to generate data, co-produce a service, operationalize the service and delivery, and inform user decision and actions, and then scale and valorize, and finally evaluate the service, and then you can start the circle again. So that's important. That's why it's a circle, because you want to continue the interaction. It shouldn't be from one end to the other. It should be a continuous process. Next slide, please. So this basically terminates my presentation. But before I leave you, I want to show you a little bit more about the Teal tool, which I mentioned before. And so I'm going to run two videos. One, which is a general video about the Teal tool to tell you what it is. And then another one is a demo to show you how that can be used. And this is a tool that can be used during our working groups starting next time. So just have a look and see what you can get out of this. And of course, you can play online. I can type the address of the service after the two videos. Thank you, and over to Dina for the video. Thanks.
In this digital age, there's a massive amount of climate and energy data out there. But if you're not an expert like Matt, going through complicated files and data plotting tools to inform your decisions can be time-consuming, overly technical, and uninspiring. Problem solved. A leading team of climate and energy data specialists led by the World Energy and Meteorology Council have done the hard work for you and developed Teal, a free, easy-to-use climate and energy interactive visualization tool. Teal shows globally how our climate and energy have changed over the past decades to near real time. With Teal, you can download data and produce graphs, making it easy to share the information with others. So, how does it work? Step 1. Climate and energy variables. By selecting a variable from the colored icons, Matt can see the first year of data available. Step 2. Map. To check the value of this variable for his home country, he can just hover over it on the map. He can also rotate the globe with his mouse to see the numbers in other countries. Step 3. Filters. Matt can also use the filters to explore additional data features. Step 4. Slider and graph. By clicking on a country, Matt can see a graph showing how the selected variable has changed over time. When he moves the time slider, the changing colors on the globe allows him to explore how the data have evolved in time. Matt can move the time slider to manually trace the shift in the selected variable across the map. Or he can click play and the time slider will start moving automatically, presenting the changes in a loop. That was easy. Now Matt can better plan ahead, reduce risks, and make better business decisions using Teal. Try Teal for free and easily explore climate and energy data.
Teal is a free climate data tool. It's designed to raise awareness about changing climate, helping you to visualize and download data. This overview will give a demonstration of its main functions and some examples of how it can be used. The first view on Teal is of the full globe. The data is from the ERA5 reanalysis dataset. The coloured buttons on the top left give a choice of variables to view: carbon dioxide emissions, solar radiation, precipitation, wind speed, and temperature. Here, temperature selected. Hovering over a country shows the value of the variable for that place. The value is also shown on the colour bar in the bottom right. Holding down the left mouse button can be used to rotate the globe. Filters can be used to change the view from countries to sub-countries and also change the temporal resolution between annual, seasonal, monthly, and daily. Using the slider, the date of the data on the globe can be chosen. Or you can click play under the slider to animate the map. To look at a particular country or sub-country area, click on the region to see a graph of the variable over time for that place. The graph can be downloaded as an image, or the data it contains can be downloaded as a file for further analysis. Teal can help look at long-term trends or particular events with labels to highlight individual data points. In addition, the mapped data can also be downloaded. We hope you'll find this a helpful tool to investigate climate data.
Sorry, so it's probably me, just to conclude. So thanks for your time to watch the videos. I just want to give you this takeaway messages from the lecture I gave. So there is a strong opportunity to develop and strengthen weather and climate services to assist with the energy transition and more generally to meet the climate goals I mentioned before, so Paris and Glasgow, and in general, the net zero emission goal. Weather and climate services are already assisting the energy and other industries to better manage their resources by embedding forecasts into their decisions. And finally, the key to successful weather and climate services is to keep an ongoing communications with users, like I mentioned, via the COCOCO approach to overcome the complexity of the information and the level of accuracy of the forecast. Thank you for your attention. I don't know if there is time for a few questions, so I leave it to Alexei to decide and then for the next steps. Over to you, Alexei. Thank you very much all.
Thank you. Thank you very much, Alberto. Sorry that I saw interruption. Thank you very much. And of course, with this presentation, previous presentations, Laurent Dubois, we start with series of very interesting presentation, which presented new services, climate and energy services. And now we have it's about the 15 minutes break. And after that break, for any technical reason, you can also have this time as free. We continue, as you can see in our agenda. We continue with also two short but very interesting presentation session with two sessions, yes. And this session was about presented Eva Birk from UNICE and Sergei Tulinov from SCAP, UN SCAP, and also the final session for today. It was the presentation. It was a session about weather climate services and services which also could be realized, it could be used for better understanding any services in Central Asia. So now is a thank you very much, dear participant, for all of participation for the first part of today's session, and we wait you. Please join us, or you cannot. Maybe you cannot to go out from the Zoom, and please come back. Return. It's in the 15 minutes. Okay. Thank you very much, Paul.
Hello, everybody, and welcome back after the break. I hope you managed to get some refreshment, tea, coffee, just stretching your legs. So welcome back to the next part of the first session of the first day. We are going to hear now two important presentations about recent trends and current status in the energy sector in Central Asia. So to do that, we have two great speakers, and I'd like to start to introduce you the first speaker, who's Sergei Tulinov. Sergei has been working for the United Nations Secretariat for more than 10 years. Sergei is currently with the Economic and Social Commission for Asia and the Pacific, so UNESCO, based in Bangkok, Thailand. He's managing projects in energy and climate to support member countries in achieving 2030 agenda and the Paris Agreement in the Asia-Pacific region. Sergei started his career in the Russian Hydrometeorological Service as an expert on climate change. Before joining the UN, Sergei was the lead negotiator for the Russian government under the UNFCCC. So it's a great pleasure to have you, Alexei, present the next presentation. And just a note for Dina, I think if you have them the other way around with Eva, please note that Alexei is next. And we have less than 15 minutes for the talk, so we can hear from Eva next and then allow for some questions at the end. So over to you, Sergei, please.
Hi, hello everyone. Can you see my, I'm trying to share my screen with my presentation. Can you see it? Please confirm.
Yes, we can.
That's great. So hello everyone. I'm Sergei Tulinov. I'm working for the United Nations Economic and Social Commission for Asia and the Pacific. I'm so happy to be with you and to speak now in front of you. And it's really great pleasure. And I'm representing United Nations Secretariat here together with my good friend and colleague, Eva. She's working for UN Economic Commission for Europe. I'm working in the sistership commission, UN Commission for Asia and the Pacific. We have 53 member states across all Asia Pacific, and working towards supporting sustainable development and Agenda 2030 and our main clients are the governments in Asia Pacific, and we are developing capacity building. We are also the intergovernmental platform to elaborate on sustainable development issues in Asia Pacific. And now I'll speak a little bit on the status of energy sector in Central Asia. And for me personally, it's a really great pleasure to participate in this meeting. As Alberto just mentioned, I started my career as a meteorologist in Russian Hydrometeorological Service, and that was more than 20 years ago. And that time, no one, as far as I remember, no one talked about weather and climate and energy services working together. It was not on the agenda in the national weather services. Also, we worked with WMO, with UNFCCC, with IPCC. Also, this topic was maybe just in the beginning that time, but now we can see really a huge benefit of energy and climate services working together, bringing benefit and co-benefits to each other, and huge benefit to the societies in developing further their sustainable energy, their climate stability, in developing their zero carbon energy future. So I'll talk more about the current status, but I'll begin with some background information, which is probably, of course, everyone is aware of. I'll make my slides in Russian or in English with some bilingual, but I'll speak in Russian. I hope everyone is fine with it. So let's begin with something what everyone knows about as sustainable development goals, and their goal 7, which is to ensure universal access to affordable, sustainable, and reliable and modern energy for all. Yeah, and there are 3 main targets under this sustainable energy goal 7. By 2030 to ensure universal access to affordable, reliable, and modern energy services. Also to increase substantially the share of renewable energy in the global energy mix. And last but not least, to double the global rate of improvement in energy efficiency. So these are the global goals. So, we'll talk more about the progress, how the Central Asian region and individual countries in Central Asia are progressing in achieving these global goals. So this is the slide which gives you a snapshot of overall SDG 7 progress in 5 countries of Central Asia. And you can see that the access to electricity has been almost achieved, almost 100%, 99%, according to the national statistics. So, which means that the goal 7.1 has been reached already. But we all know, of course, that there are some issues behind this, and technically the 100% electrification has been achieved, but we know the issues and the challenges with the electricity sector in Central Asia in terms of reliability, in terms of the pricing, in terms of the energy mix. So there, of course, there is a room for improvement, and we, as the UN with other partners, we've been supporting governments in Central Asia in improving the quality of service of electrification. So also we are talking about access to clean cooking. This is another indicator to achieve sustainable energy, and it has reached 88% in Central Asia. By clean cooking, we also consider LPG or gas, and also electricity has been widely used in Central Asia for clean cooking. Another important, and I'll talk about it, of course, more in my presentation, another important indicator is the share of renewable energy, and in particular modern renewable energy in the electricity mix in Central Asia, and it has reached 14% of the total final energy consumption. This is another indicator which describes the performance, the achievement, the progress towards sustainable energy 7. But the lion's share of it in Central Asia is hydro energy. We all know that. So the share of solar or wind is actually a fraction of overall electricity mix in Central Asia. Yeah, and in countries like Kazakhstan, it has reached 2%, but in other countries, highly depend on fossil fuels in their energy mix, this is even less. And the last but not least indicator which describes the progress in energy efficiency is energy intensity, which is which is basically a ratio between the total energy supply and the gross domestic product, measured in US dollars. So the average is the global average is 2.4, but 2.8, but the average for Central Asia is 8 megajoules per USD. So there is also it's gradually decreased from 1990. And in some countries, I'll show it in my next slide, it's really almost close to the global average, but the energy efficiency is still really huge potential to meet in Central Asia. Basically, it's with many sectors of energy intensive sectors of economy in Central Asia, like buildings, like power sector, of course. There is an infrastructure which is outdated, which requires modernization or replacement. That would definitely improve the energy efficiency situation in Central Asia. Let's move on. I don't want to emphasize on some slides because I have quite limited time, and my colleague Eva would take over with really fantastic information about low carbon pathways in Central Asia. I'll skip this slide about clean cooking access and jump directly to the primary energy supply in Central Asia. And this slide shows you the distribution of main energy resources, the basically of energy mix in Central Asia. And you can see that the energy mix in Central Asia in countries, in particular countries like Kazakhstan, Turkmenistan, Uzbekistan, is mainly based on fossil fuels. This is quite obvious because they rely on the abundant natural resources, and these are mainly oil, coal, and gas and hydro energy. And you can see that's the primary energy supply by resource in Central Asia. My next slide is to support also my previous statement on the abundant natural resources in this region, and this is how the electric power plants have been located in Central Asia, and it's clearly, of course, correlated with the reserves of natural resources. And you can see the upstream and downstream countries. So the upstream countries closer to the mountains, rich of hydropower, such as Tajikistan and Kyrgyzstan. And then we go up north with the countries who's been mainly depends on oil and gas in their natural resource, in their electricity mix, and coal in the areas rich of coal, such as Kazakhstan. And this is the installed power plant capacity in absolute units here in the right part of this slide. So definitely power plants installations, they zoned based on coal, natural gas, and hydro in this region. So the next slide on the production of electricity in Central Asia, and also you can see that mainly the most lion's share of electricity has been produced from oil, coal, and natural gas, and hydro energy. And you can see the distribution by countries. And Kyrgyzstan and Tajikistan, of course, one of the richest countries in the world of hydro energy. But Kazakhstan, Turkmenistan, and Uzbekistan are mainly fossil fuels. Turkmenistan, of course, 100% natural gas. And the quick snapshot on energy intensity, what I mentioned in the beginning of my presentation, and also we see the highest energy intensity in Turkmenistan, also because it's 100% depends on natural gas, which doesn't provide much incentives to develop renewable energy sources and to impose energy efficiency measures, although the government of Turkmenistan has been doing a lot to achieve this. But you can see all Central Asian countries, energy intensity is higher than the global average. So let's move on within the remaining 4 minutes I got. Let's move on and talk about renewable energy resources. And we can see also that's the installed renewable capacity by resource. And as I've mentioned, it's renewable energy in Central Asia is primarily derived from hydropower, and other resources have yet to contribute significantly to the energy mix, with the exception. So now actually this data is a little bit outdated because Kazakhstan has larger share of solar and wind than been shown here, as well as Uzbekistan has been progressed tremendously. In new installations of solar, but still it's been heavily dominated by hydropower. And since we're talking about energy services and climate and weather services working together, I think this is the perfect example of how one of the examples, of course, of how they can work together and how the meteorological and climate information can support in making policy decisions in energy planning. And this is the map of wind speed and wind potential in Central Asia. And these yellow circles are the current wind power plants locations, which been already built or under construction. So, and you can see that there's a huge wind potential in Central Asia, which is still unmet, and which also, and the studies and climate science and weather science can really support in identifying the best locations of for wind power installations. And same with the solar potential, same with the solar power plants. These are the solar potential map of Central Asia with these blue circles of actual solar power plants, which have been already constructed. Maybe a few haven't been just announced or under construction, are not yet on this map. This map is from 2019, but still it demonstrates the fantastic, tremendous potential for solar power in Central Asia, and definitely weather services and energy services, energy authorities should work together in exploring more opportunities for construction of solar power plants in Central Asia. And my last slide is about the existing power transmission networks in Central Asia. While talking about energy mix and energy situation, we definitely have to underline the importance, the great asset the Central Asian has got. This is the unified electric power system of Central Asia. So it's inherited from the Soviet Union, and it's still under operation with certain limitations. But this, for all energy systems, power systems of Central Asia being united, being interconnected, this is really can be utilized to accelerate renewable energy penetration in these countries. Also to use this system as a kind of a storage or reservoir for renewable energy, and with modern dispatching system, which of course has to be modernized and improved. And in particular, we know that a few weeks ago, during this really huge cut of electricity in Central Asia. So, but overall, that system has a huge potential in terms of further penetration of renewable energy in Central Asia. So this is the very brief explanation, very brief snapshot of what's going on in Central Asia in terms of energy situation. And I'd like to ask you to visit Asia Pacific Energy Portal, which is also bilingual and which is also available in English and Russian, which is run by UNESCO, where you can find much more information about energy sector across all Asia Pacific and all countries in Central Asia. So my last point that yes, Central Asian countries has a really tremendous challenge in designing and resetting the energy system, in designing them in a way to align with carbon neutral pathway with their commitments on the Paris Agreement. But this is really doable, and this is really can be achieved. But how? I'll give the floor to my colleague Eva to tell about this more. Eva, please, you have the floor.
Thank you so much, Sergey, and thank you for this fantastic presentation to set the scene. As Sergey has already said, ESCAP and UNECE are working together on accelerating energy transition in Central Asia. This is one of the regions that we share. And where we are joining forces in helping countries to achieve their targets and decarbonize their energy system. So I would like to ask technicians to share my presentation as well, or would you prefer me to do so? Okay, fantastic. Great, so let's go first directly, let's dive into the content. Now we understand based on Sergey's fantastic presentation, where we stand, what is the status, current status of the energy system and energy mix in Central Asian countries. I would like to spend next couple of minutes, 10 minutes to take a forward-looking approach and explore different pathways that will get us to attaining carbon neutrality in UNEC region for a start, but for focusing mainly, of course, on Central Asia. So let's go to next slide, please. Next slide, please. So this is, here I would like to tell you what was our starting position. We asked ourselves and our experts at UNECE how to get to carbon neutrality, how to attain Paris Agreement targets. And we learned from our analysis, our data collection, that UNEC region, this is North America, Europe, and Central Asia, need to cut or capture 90 gigatons of CO2 emissions by 2050 to meet Paris Agreement targets. We then zoomed in for Central Asia, and the data and analysis has shown us that the region needs to contribute to about 10% of these objectives, with 90 gigatons of capturing or decreasing CO2 emissions by 2050. And there will be really a variety of technology pathways. Our analysis and consultations with a wider expert community concluded that in order to attain those ambitious objectives, a range of zero and low carbon technologies will play a role. So as we heard from presentations earlier today, renewable energy needs to be first priority and needs to be deployed and at scale. But the reality is that there are some sectors, some hard to abate sectors that cannot be really easily decarbonized solely with renewable energy sources. That's when we started really thinking with our community, what are those innovative technologies that will need to play a role, that need now some policy support, some investment support to emerge before they become commercialized. So in the next couple of slides, I would like to just briefly draw your attention to some innovative technologies such as carbon capture, use and storage, or hydrogen, technologies that we analyze and assess more into detail, and that can potentially help also countries in Central Asia to attain carbon neutrality and decarbonize their complex and now energy carbon intensive and energy intensive sectors in Central Asia. So these are a couple of products that we have ready. I will share them later in the chat. We have them in Russian and English language. Let's go first to look at our value chain of the carbon capture, use and storage. This is on the next slide, please. So we looked at the portfolio of carbon capture, use and storage technologies. And we concluded that, and our experts, that CCUS can be a viable climate mitigation option for many countries in the whole UNEC region, but can definitely play a role also in Central Asia, given that the region still heavily relies on fossil fuels and is rich in those resources. So in order to, of course, to make CCUS commercial, there are a number of there is a need really for a policy push for investments, and policymakers should start thinking like how to really incorporate CCUS as a solution in climate mitigation action policies, and to see what are those policies that can really help CCUS to be implemented and embraced today, and finance to be a solution in the medium term. Next technology on the next slide that we also looked into was nuclear power. For countries that decide to use nuclear power as a solution to attain climate mitigation, climate targets, it can be an important source of low carbon electricity and heat. In our analysis on attaining carbon neutrality, we looked at innovative nuclear power solutions such as small modular reactors, which which have potential and can play a role in decarbonizing energy system across the region. To some extent in Central Asia, and of course on the aggregate UNEC level, we noticed that in a number of regions and countries in UNEC region. Next important technology that is gaining more and more attention when discussing how to attain carbon neutrality, how to decarbonize energy system, is hydrogen. We assessed, as you can see on this infographic, we assessed the whole hydrogen value chain. And hydrogen really can be a solution also in Central Asia. At the moment, UNECE is conducting or actually implementing a project on sustainable hydrogen production pathways in Central Asia. Also later in the chat, I can share some more information. So if somebody from this community would be interested in joining UNEC task force on hydrogen and understand how hydrogen can play a role in your respective countries, please get in touch with us and I would be happy to involve you in that work. So these were like the three technologies that, of course, with renewable energy as a #1 priority, can and should be taken into consideration when now developing long-term plans and strategies in decarbonizing energy system towards the mid of this century. So I would like now to spend some more time showing you some data. I think it's more interesting to also see like what are really those pathways or those technology pathways that will get us to carbon neutrality in the Central Asia. So please let's go to the next slide where I would show you a couple of different scenarios. Please also know that this is still preliminary data. We are in the process of finalizing this data for Central Asia. So if you're again interested, reach out to me and I can involve you also in our task force on carbon neutrality. We look here at 3 scenarios. We look at the reference case, which is basically business as usual, with, of course, already some climate mitigation policies factored in. Then we look at the carbon neutrality case. This is a scenario where we model like how to attain carbon neutrality by 2050. Here we are factoring like more ambitious climate targets based on the national determined commitments, based on the pledges made. And our starting position is really like what is committed, what is pledged today, and as of the COP 26 that took place last November. So what are those ingredients and how we get to carbon neutrality by 2050. The third scenario on your right hand side is we call it carbon neutrality innovation case, and here we put little bit, we factor some assumptions which are thinking more on those innovative technologies that I just presented to you, like how are we going to get to carbon neutrality if we, and how much it would cost if we put more pressure into, or more ambitious policies into CCUS, carbon capture, use and storage, hydrogen, or innovative small modular reactors of nuclear power. So just for you to understand a little bit what is our methodology. This slide shows primary energy supply for Central Asian countries on an aggregate level. As we can see, the mix is dominated by fossil fuels, and even in the ambitious climate mitigation scenarios, fossil fuels will to some extent continue to play the role. But later in the slides, you will see that these fossil fuels that will still be used for the primary energy supply, the CO2 emissions will be offset through CCUS technologies or even hydrogen in order to attain carbon neutrality. So really for a Central Asian region, given the current energy mix for some countries and potential to store CO2, such as but there is potential in Kazakhstan, it is also in Turkmenistan, CCUS can play a role in attaining carbon neutrality. Let's go to the next slide, please, where we show final energy mix. This is the energy consumed by end users, so in households, industries. And as you can see on the chart, with more ambitious climate mitigation scenarios, these final energy supply or energy mix will become more and more electrified. This is also in line to everything what we heard from Sergey and colleagues earlier today. We are seeing here quite some structural changes in the final energy mix. It's on the back of course, more energy efficient uses of energy on that demand or end user side, but also changes in different sources. And while to some extent fossil fuels will remain in the mix, still increasing penetration of electricity will be gaining the share. And we still also see emergence of hydrogen as a potential source for final energy use in industry, in transport. We will see it on next slide, which can help us to decarbonize some hard to abate sectors. So here, I would like to draw your attention to industry, to final energy mix in industry. We see again that there are some structural changes, processes that will be that can be electrified will be electrified, and those that cannot be easily electrified will need to be really reconsidered and explore what are those technologies, what are those low and zero carbon technologies that can decarbonize those sectors. At the UNEC, we looked at the decarbonization of cement sector, steel production, and chemicals production. And for cement sector, we learned from analysis that CCUS can play a role, a significant role to decarbonize those plants which are run by coal and gas. Then we also learned that in steel sector and chemical sector, hydrogen will increasingly play and can play, and we believe that in this carbon neutrality case, it will increasingly play a more important role to decarbonize those sectors. So this is a scenario or picture that we are imagining for industry. If we go next to have a look at the building sector, here we're also, please next slide. We're experiencing structural changes on the demand side. So building sector will really go through significant changes, and there is really need for a policy push, but also investments. Heating and cooling will be electrified. There is also a need for retrofitting building sector and improving energy efficiencies. We are seeing it significantly in the eastern part of UNEC region. And here I would like to also connect to the first presentation that we saw earlier today, where the UNEC status report was highlighted for Eastern Europe and Central Asia. The document is now in a final stage, and it will be published in a couple of weeks, less than a month. And from that analysis, we also learned that there really is a need for retrofitting of the building sector in Eastern Europe and Central Asia. So what you're seeing on the slide, there is really need for more more retrofitting of the current building space that we have, and which is unfortunately as of now not efficient. And last, I would like to show you a slide where we look at in detail in the electricity generation mix in Central Asia. So this is the next slide, please. Few times I mentioned today that the energy mix on the final energy mix will become more and more electrified. Of course, it will be on the back of the deployment of renewable energy sources. We saw that also in the presentation of Sergey. And the Central Asia region is really abundant in renewable energy sources, a lot of hydro, solar, and wind potential that needs to be further explored and used and utilized. So, but there is a fact that at the moment the region is to quite some extent relying on fossil fuels. And as we are seeing on the carbon neutral case, there really is a need for carbon neutral use of fossil fuels if they will remain in the mix. So even for the electricity generation, we see that CCS will play a role, and something that needs to be taken in consideration and looked into detail. We are still tweaking the assumptions behind those figures and outputs. But what the signals from the region show us and the trends from different regions, which are then extrapolated for Central Asia, this is a trend that we are expecting for when looking at the electricity generation mix when attaining carbon neutrality by 2050 in Central Asia. So just like a couple of key takeaways on next slide, please. We should acknowledge that the region countries are committed to net zero targets. So we are seeing signals and ambitious policies from a number of and from a number of countries in the region. The national action plans are being developed, but there still is a need for capacity building, and really UNEC and ESCAP stand here to help policymakers to develop those national plans and really explore like what's the most optimal pathway for respective countries. As we said, and that you can see in the data, there really be a variety of pathways, and for different countries, different technologies will play a role based on their natural resources and current infrastructure in place. So there really is a need for a rapid transition from fossil fuels. It will not be easy, but there needs to be a push for large-scale deployment of renewable energy and other low and zero carbon technologies for processes, for industries, for sectors that cannot be easily decarbonized with renewable energy sources. We noted—
Sorry, Eva,
yes,
we need to wrap up.
So transition will be really uneven and will affect various sectors. So there really is need for clear regulatory framework and effective capital allocation. And again, here UNEC and ESCAP can help countries attract those resources, share best practices. So again, I will be a little bit active now in the chat and share a couple of resources with you. And if you wish to engage and work with us, please reach out to me. Thank you, Alberto. Sorry if I got over time.
Excellent. Thank you very much, Eva and Sergey. That was fantastic overview and scene setting for all the discussions we're having in terms of the local knowledge. That's plenty of information to work with and very, very useful. So we skipped Eva's bios. I'll just go quickly. I know we're running over time and sorry for the next session, but it means that hopefully everybody can stay for additional 10 minutes at the end. And so we'll finish at 12:40 UTC rather than 12:30 as planned. So Eva is an energy analyst who's been dedicatedly pursuing a career in energy industry internationally. She has worked for INES, International Atomic Energy Agency, IAEA in Vienna, PetroChina in Beijing, energy consultancy Westwood Global Energy Group in London. And in 2018, she joined the Croatian Ministry of Foreign Affairs, where she worked as energy trade and sustainable development specialist. And after a diplomatic mandate, Eva joined United Nations Economic Commissions for Europe, UNSCE, in Geneva to work on sustainable energy portfolio. So we're grateful for Eva's contributions, not only today, but also to shape the program with Sergey and their contribution again, UNSCE and UNESCO to the whole program composition. So I'll unfortunately, as I said, we run out of time for questions, but please do use the chat to ask questions to Eva, Sergey, everybody that spoke before. And we now need to move on with the next session, a panel session chaired by Barbara. You met Barbara before, but she wasn't actually introduced properly because she was chairing. So I'll do a quick introduction of Barbara Janus Pauleta, who has a PhD from the Free University Berlin and a master's at Jagellon University. Currently, she's the Vice President for International Cooperation, UNESCO Chairholder for Water Resources Management at the Kazakh German University. Since 2011, Barbara has been on behalf of DAD, is building up and supervising the regional master's program on integrated water management in Central Asia at DKU. And since 2016, she's a UNESCO chairholder for water management in Central Asia. And her research has been published on more than 35 papers and documents. She's also the editor-in-chief of the Central Asian Journal of Water Research. She's a member of the technical committee of the Global Water Partnership and of the International Law Association within the committee role of international law and sustainable natural resource management and development. And on it goes, but we'll stop here because otherwise we take too much time from the panel discussions. And apologies again to all panelists, all participants for the delay And over to you, Barbara. Thank you very much.
Thank you very much. Also, thank you for the kind introduction. I did not even think that I have such a long biography already, but it's good to remember sometime. Just a joke. I'm really happy that you have struggled so long and stayed until now, until we have a panel together, because this is the first day of 6 intensive days of trainings. But we really hope that that you enjoy it, that you learn a lot, and we are taking all the efforts to make it interesting for you. And I'm sure that this panel, which is on the screen presented to you now, where Jane, Alexei, Aset, and Ainur will be speaking, I'm sure that it will be lots of good learning for you, and opportunity also to exchange with the experts. So without further ado, I will be moving to give the floor to Jane Ebinger. She's representing World Bank. She's Chief Climate Change Specialist at the World Bank, and she was actually one of the first person who was we have consulted to set up this program for Central Asia. But Jane, she's also supporting the Vice President of the World Bank and Special Envoy for Climate Change and climate change across cutting solutions areas on climate policy and finance. I think that's all the mixture of her very big experience in the climate change and in the energy sector, as well as her professional experience from before joining the bank while working in the oil and gas industry of BP and BHP Billiton is very important to us. And I was really impressed by learning that her MA is in mathematics and an MSA is in mathematics and modeling and numerical analysis from Oxford University. I think that's very impressive. So Jane, still, even with such an impressive CV, you have just 5-6 minutes to be very brief, because we are a little bit over time, and then we go into the questions. Thank you, Jane. Floor is yours.
Thank you very much, Barbara, for the very kind introduction. I had a couple of slides. Will someone show those for me? Okay, if we could move to the first slide. So welcome everyone. Thank you for having me today. What I wanted to do was focus on 3 key objectives today. The first is to understand how energy and water systems are interdependent and how they're vulnerable to climate change. I want to focus on weather and climate services and how they can support the energy transition. We've touched on some of that already today, and also reflect on what some of the gaps in service are that need to be addressed to be able to support the energy transition in the future. Next slide, please. So why do we need weather and climate services for the energy transition? What this slide shows is that energy and water systems in the region are very interdependent. The energy sector needs water for hydropower, thermal cooling, to extract fuel, refine it and produce it, but it's very vulnerable to water issues. For example, if you have decreased water availability, that can reduce your hydropower capacity. And at the same time, the region's economy is very reliant on water to feed irrigation for agriculture, and there's a very high water withdrawal and energy use associated with that. Next slide, please. From a climate perspective, energy and agriculture are leading drivers of greenhouse gas emissions in the region. And water stress, which is already very high, is increasing across the region. Demand for water is expected to intensify as the population grows and the economy grows into the future. By 2035, the IEA estimates that water consumption is expected to rise 35% globally, and with it, water consumption will rise 85%. So if you look at Central Asia, together with an increased demand for water and with climate change, we're likely to see further increases in the variability and intensity of rainfall, increases in flooding that could worsen sediment flows to reservoirs, shrinking glaciers and impacts on the amount of water that can be stored in lakes, wetlands, and groundwater, and reductions in the reliability of water supply for all sectors of the economy, whether it's water, agriculture, or energy. Next slide, please. So climate change will have very wide-ranging impacts on energy systems, as has been mentioned earlier. As renewable energy is scaled up, whether it's wind, solar, or hydropower, the region will become increasingly weather and climate dependent. So what this means is that weather and climate services are going to be needed to guide the operation of these systems and to help with the long-term planning and coordination of these systems and the users, so that they can be managed more sustainability and we can maximize productivity. Next slide, please. So one of the key questions is what's going to change in the future? How can weather and climate services support energy transitions? And I just wanted to talk about one example. So Central Asia has lots of tools to address water and climate challenges. For example, as you can see here, there are significant hydropower resources that can be scaled up to increase renewable generation capacity and to balance and stabilize the energy system as thermal power is replaced with wind and solar, which are more variable. Also, if we increase green water storage by developing these resources, we can help increase climate resilience. And we can design these so that they support regional development in a way that's inclusive, support nature-based solutions, and help catalyze innovations in financing technology. So in Central Asia, many hydropower assets are underdeveloped or outdated and poorly maintained, and the average age of these assets is about 40 years old. For example, in Kyrgyz Republic, the power sector is dominated by hydro generation, but it's experiencing an increased supply-demand deficit risk, and only 10% of its hydropower has been realized. So this is one of the opportunities. Next slide, please. So where's the opportunity for the weather and climate services? Well, they can help inform these investments, such as new storage or rehabilitation of existing assets, so they can realize their full potential. But if they're going to do that, what weather and climate services need to be able to deliver is information on the nature and timing of climate impacts and how climate parameters will affect energy and water systems. They need to provide information that is tailored to users on a range of timescales. So that's daily, weekly, seasonal, and also longer term, so that asset design can be improved and operations can be managed. And we also need some regional information to minimize the impact of resource use in one country in the region on other countries, and so that we can optimize and ensure that net benefits are shared across all countries in the region. Next slide, please. So if we want to realize these opportunities, what we need to do is strengthen weather and climate service provision. And there are three ways that we can do that. First, we can turn weather and climate data into actionable information and services to support energy planning, design, and investment. For example, to inform the operating rules for hydropower cascades, to enable water supply, energy generation, to protect from flooding, and improve overall the safety, reliability, and efficiency of operation. Existing weather and climate services will need strengthening to meet WMO standards, as we've heard, and to be able to document current climate trends and measure how, where, and for what water is used. And gaps in observation network coverage and its maintenance and operation will need to be closed. The second thing that we can do is build capacity and coordination for weather and climate services at multiple levels, from local to regional. This is the capacity to design and manage weather and climate networks, and strengthen gaps in climate services, IT, and engineering. There's also a need to have a look at data quality and data management. So this includes things like introducing climate data standards, checks and management systems, moving towards open government data policies and cooperation standards on data and system operation so that we can build technical capacity for future interoperability of these systems in Central Asia. And most importantly, as we've heard earlier, weather and climate products and services need to be co-designed with users in key sectors like energy, agriculture, and water. And this could be supported with platforms that allow regular and systematic exchanges between users of that information, ministries and agencies that produce that information, and partners. And the third thing that we could do is to complement this by leveraging existing institutions to optimize the management of regional energy and water systems. For example, to improve weather and climate services, optimize regional reservoir operations, and connect regional power infrastructure. There are several regional institutions that have been established to improve regional coordination on different issues and with different modalities, including the International Fund for Saving the Aral Sea, the Central Asia Regional Economic Cooperation Programme, and the Central Asia Regional Environment Centre. But while all of these institutions have considered some nexus issues in the past, presently, none of them have a strong or clear mandate for tackling nexus issues regionally on behalf of the governments of the region. Next slide, please.
Jane, if I could ask you to round up because we are already
Yes, I am. Yes.
Thank you.
And so this is just a caution. There is a risk if we don't act now. And this was a quote I came across as I was preparing for this presentation. And I think it's worth mentioning. There's a tall wall between our scientists and our decision makers. Scientists do research and lob their information over the wall, hoping someone on the other side will catch it in receptive hands and act on it. However, what's on the other side of the wall is a big pile of papers and information that decision makers pay no attention to. So what we really need to think about is how we break down that wall, and that's a key role for weather and climate services. Last slide. So these are the key takeaways. There is a significant opportunity to support the energy transition if we can translate data into actionable information and services, close capacity gaps, and optimize regional management. Thank you.
Thank you very much, Jane. Thank you for this very enlightening, also setting the stage. I'm sorry that I'm kind of pushing for the time, but I think it's in the general interest of everyone also to get into a little bit of more discussion. Thank you so much. And without further ado, let me now invite for a short presentation Alexei. Alexei Kobzyev is a person who you know already, and he was already introduced by Alberto. So I think I can skip that part, and then we have saved 1 minute more. So Alexei, you have 5-6 minutes, the same. So I'll be giving you the sign when we are a little bit over time. So please go ahead.
Большое спасибо. И в продолжении таких интересных презентаций я хотел бы тоже перейти немножко более к практическим инструментам, которые позволяют на практике именно непосредственно увидеть, попробовать и спрогнозировать, может, в некотором смысле даже потребление энергии, в частности, выработку энергии, которая может быть произведена, в частности, с помощью тех сервисов, которые есть в Центральной Азии. Первоначально я хотел остановиться на сервисах, которые есть также в международном режиме, в международном масштабе, но поскольку мои коллеги, представители международных организаций различных, рассказывают уже о целом ряде таких инструментов, которые позволяют использовать климатические и погодные сервисы для прогнозирования выработки энергии для других целей, да, то я хотел бы остановиться именно на тех сервисах, которые касаются Казахстана. И чтобы перейти непосредственно уже к делу, я хотел бы вот обратить ваше внимание еще раз на такой существующий и развивающийся, между прочим, ветровой атлас Казахстана. Он размещен, в частности, вот вы можете видеть его на ссылочка ведет через сайт Kegok, через Kegok. Да. Значит, этот атлас, он представляет собой долгосрочные исследования, которые первоначально проводились проектом ПРООН более 2 лет, практически 4 года, и потом они еще продолжались в течение 5 лет. И он тоже интерактивный, и он позволяет видеть наиболее перспективные места, в первую очередь, для построения ветровых электростанций. Вот вы видите сейчас один из скриншотов этого атласа, интерактивного атласа. Пожалуйста, следующий слайд. Следующий слайд. И вот какие непосредственно, в частности, нет, назад, пожалуйста. Да, вот этот вот, ага. Значит, какие он представляет возможности, непосредственно какие параметры он показывает. Ну, на самом деле было проведено исследование по огромной территории на высоте примерно 80 метров, то есть это наиболее та оптимальная высота, при которой строятся обычно турбины, для того, чтобы с одной стороны, не делать слишком инженерно сложными процесс построения ветровых электростанций, потому что выше 100 метров это уже наступают там другие большие сложности определенные. И в то же время это такая скорость, на которой скорость ветра достаточно уже оптимальна, достаточно высокая, потому что уже не препятствуют какие-то относительно невысокие поверхностные преграды, в частности, будь то лес или здания, или какие-то такие объекты небольшие. Вот. И вот этот вот атлас, он сделан с расчетом скорости ветра на высоте примерно 80 метров. И резолюция, то есть масштаб нанесения точек, условно говоря, на этот атлас, он варьируется, потому что Казахстан огромная страна совершенно, и он варьируется, некоторые точки от 9 километров, то есть одна точка, условно говоря, на 9 километров, и до практически иногда даже 100 метров идет резолюция, то есть каждые 100 метров замерена скорость изменения там, где это действительно обосновано. Понятно, что если это степь, которая на 50 километров или на 100 километров, на 200 километров, то там просто не имеет смысла каждые 100 метров делать замерение, потому что нет никаких оснований для того, чтобы скорость ветра менялась. Так вот, кроме того, значит, ветер, региональные данные также использованы, региональные данные, локальные знания и свободное флагирование использовалось для того, чтобы создавать этот атлас. Пожалуйста, следующий слайд. Значит, как и для чего можно использовать этот атлас, кроме того, что знать и понимать, где потенциально могли бы быть построены ветровые электростанции. Значит, наряду со скоростью ветра этот атлас также использует очень много достаточно дополнительной информации, такую как топография, определенные экологические аспекты. Он используется, он же также сделан с учетом существующей уже проложенной электрической инфраструктуры. Он делается с учетом того, где наиболее эффективная земля для вегетации, да, определенной территории. Также он сделан с учетом того, куда потом можно было поставлять эту энергию, потому что понятно, что если производить ее очень далеко и потом поставлять, определенно идет потери. Да, и с учетом также региональных и локальных финансовых мотиваций. Как это может быть использовано? Карта может быть так же, как распечатана, так же, как использовать как GIS программное обеспечение. Пожалуйста, следующий слайд. Ну вот здесь вот немножко дается более подробная информация, как проводились замеры. Замеры проводились как среди уже первоначально планируемых строить станций. И действительно в этих местах были потом построены станции. Это и Кардай, это и Каркаролинск, Ерментау, вы прекрасно знаете. Форт Шевченко еще не построено. Аркалык, в районе Атерау, в районе Астаны. В районе Астаны уже несколько, вы знаете, построено больших станций. Пожалуйста, следующий слайд. И теперь я хотел бы перейти к солнечному атласу Казахстана. Он делался компанией Комтех по заказу программы развития ООН в Казахстане. Это тоже, с одной стороны, это карта, которая, несколько разных карт, которые можно использовать в качестве просто карт для того, чтобы определить уровень инсоляции, то есть уровень максимального или среднего потребления солнечной энергии и, соответственно, эффективности выработки солнечной энергии с помощью солнечных панелей. А также этот инструмент можно использовать как интерактивное средство. Вот, пожалуйста, следующий слайд. Значит, в самом инструменте, который, вот, кстати, вы можете вот увидеть по адресу atlassolar.kz, я также постараюсь дать эти ссылки и ветровой атлас, и солнечный атлас в чат нашего тренинга. Так вот, солнечный атлас Казахстана, он разделяется, условно говоря, на 4 основные блока инструментов. И вот основной первый блок инструментов – это, собственно говоря, и карты солнечной радиации и индикаторы, такие как рассеивание, прямое попадание. Вот. Использовались данные здесь NASA SSE, Sustainable Building, SARA-E и другие данные для этого блока. Если вы на сайте зайдете, вот там вот 4 такие блока прям есть, вы увидите. Если вы на сайте этого Atlas Store зайдете вот в этот раздел, то там целый ряд интерактивных и таких карт размещен. Пожалуйста, следующий слайд.
Alexey, if you can round up a little bit your last minute.
Yeah, about 2 minutes and I will finish. Да. И второй блок – это факторы, влияющие на инсталляцию, и Grid Connected Solar Power Station, то есть солнечных станций. Это карта факторов, влияющих на потенциал, на перспективность построения солнечных станций, учитывая природные ресурсы, инфраструктуру, территории, где можно, где нельзя строить. Пожалуйста, следующий слайд. Четвертый блок – это все блоки, это все не карты. Туда заходишь, и в каждом из этих блоков можно получить целый ряд очень интересной и подробной информации, и даже прогнозы можно видеть. Третий блок – это карты основных метеорологических характеристик, таких как температура воздуха, температура поверхности, облачность, атмосферные осадки, эффект альбедо и другие. И, пожалуйста, четвертый блок. Следующий слайд. И, собственно, Solar Energy Facilities. То есть это идет привязка карты к существующим и проектированным солнечным станциям. И также карта энергетических линий электропередачи в Казахстане. Это вот основная информация касательно солнечного атласа. Пожалуйста, дальше. Да, этот слайд является у нас вот фактически завершающим. Пожалуйста, да, все. Да? И что я хотел бы сказать, несмотря на то, что солнечный атлас был создан чуть позднее, ветровой атлас был создан раньше, но тем не менее, учитывая, что они не остаются неизменными, они продолжают развиваться, это очень хороший и практический инструмент, и я абсолютно уверен, что на самом деле достаточно глубоко его изучили, на самом деле только, может быть, действительно специалисты, которые было необходимо получить вот эту информацию, именно вот, может быть, в первую очередь для построения солнечных ветровых станций, но на самом деле там есть очень много дополнительной информации, именно касающейся не только климатической информации, но даже информации, связанной с facility. Большое спасибо. Это все. Благодарю.
Thank you very much, Alexei.
Да, вы
Thank you
можете
very
говорить.
much. I mean, we are a little bit under time pressure, but I hope that in the discussion we can expand a little bit. And without further ado, I would like to now give the floor to Aset Naurizbayev, who is the former president of KIGOC and department director of Inter-RAO, and also previously advisor to the chairman of the board of system operator of Unified Energy System of Russia. He has also experience in banking system, while he was a deputy chairman of the board of KZI Bank of Kazakhstan. So Aset, please, floor is yours. And again, you also have like 5-6 minutes.
Если можно дать мне возможность показывать экран. Да. Вот. Ну, пока вы мне даете возможность показать экран, да, вот мне просто нужно по нему вводить указателем, поэтому лучше бы я бы свой экран показал. А пока вы мне даете возможность, я хотел просто рассказать, я поскольку работал в 2 операторах систем электрических сетей, то есть Transmission System Operators они называются, то я хотел бы рассказать, как они работают. И, значит, важнейшим моментом планирования режима, а режимы всегда планируются, то есть системный оператор не просто ждет, когда вот там возникло потребление, там возникла генерация, а он планирует с разными периодами. Вот. И важнейший период планирования – это период на сутки вперед. И вот когда мы говорим о планировании на сутки вперед, то, значит, у нас как раз появляется потребность в оказании метеорологических услуг. Вот. Европейские системные операторы, они очень глубоко заинтересованы в получении прогнозов солнечности и ветра, потому что это влияет на организацию всей энергосистемы. Поэтому вот эта вот работа по построению моделей солнечной активности, вернее, инсоляции и ветровой нагрузки, она позволяет достаточно точно угадывать с режимами работы энергосистем. Вот это первая очень важная прикладная часть работы метеорологов в энергетике. И вот европейские энергетики, конечно, они это очень сильно получают поддержку от европейских метеорологов. Теперь, что касается... Так, я пока еще не могу подключиться к карте. То есть я все-таки прошу меня дать возможность экран расширить.
В общем, я так понимаю, что мы технически пробуем. Просто у нас есть одна общая презентация для всех, где все включены. Сейчас
все, окей, у меня уже появилось.
Переключиться на вашу презентацию. Появилось? Хорошо.
Ага, окей, вот у меня просто нужна мышка.
Видим.
Ага. И второе, что я хотел сказать, это вот как раз рассказать о том, как работают наши передающие сети. Там вот здесь в синем это самые мощные сети 500 киловольт. И вот это пресловутое Центральноазиатское кольцо, которое отключило недавно у нас 2 республики и еще там часть Казахстана. Вот. И как видите, оно заходит на территорию Кыргызстана, вот идет здесь вот Токтагульская ГЭС, самая наша главная станция. Во-первых, она очень мощная, во-вторых, она осуществляет регулирование режимов всего района нашего, то есть там очень большая возможность по регулированию. Соответственно, здесь за ней стоит каскад ГЭС вниз по течению реки Сырдарья. И дальше через Узбекистан Сырдарья попадает в Казахстан и попадает уже в Аральское море. И вот здесь у нас вопрос климатических изменений очень важен, потому что вот верховье Сырдарьи – это после слияния Нарына с Карадарьей. То есть Сырдарья образуется вместе слияния Нарына с Карадарьей. Вот Верхний Нарынский каскад очень важен. То есть вот это вот Токтагульское водохранилище, оно обеспечивает многолетнее регулирование энергетической системы. В каком смысле многолетнее? Там такой большой объем воды накоплен, что оно может регулировать диспропорции, возникающие в маловодные и многоводные годы. То есть примерно раз в 10 лет проходит цикл маловодных и многоводных лет. Исторически так было. Но последние изменения климата, значит, показывают, что маловодные годы затянулись. И вот это вот очень интересное наблюдение сейчас, как будет происходить то есть период маловодный, период, насколько долго будет проходить. И вот это вот, значит, наличие Токтагульского водохранилища, оно раньше позволяло регулировать подачу воды по низовьям реки Сырдарья и обеспечивать сельхозпроизводство вот в районе, значит, Казахстан, Узбекистан и там, Ферганская долина. И поэтому вот то, что сейчас происходит с климатом, очень важно не только для энергетиков, но и для сельхозпроизводителей. И, конечно, у нас есть какая-то некоторая здесь противоречие между интересами энергетиков и интересами, скажем, сельхозпроизводителей, потому что энергетикам важно, чтобы мы воду сливали с Токтагула зимой очень активно, потому что зимой энергетика нуждается в киловатт-часах, а в то же время всем сельхозникам вода нужна весной и летом, когда идет вегетация, когда нужно поливать растения. И вот эта история, она сейчас находится в явном противоречии, сейчас применяются разные способы для того, чтобы это противоречие решить. Но решить это противоречие можно было бы, реализовав проект еще одной станции вверх по течению Нарына. То есть здесь есть так называемая каскад Камбаратинских ГЭС. И если бы здесь можно было накапливать воду не в многолетнем режиме, а в однолетнем режиме, то, допустим, накопив воду в летний период, ее можно было бы спускать зимой, но она бы не шла бы на поля, а она шла бы в водохранилище Токтагула. И уже из Токтагула она бы выходила бы дальше весной-летом, когда она нужна для полива. И вот это один из способов решения противоречия между энергетиками и сельхозниками. Вот. И, конечно же, вот строительство этой станции, оно позволяло бы решить проблему с долгосрочным резервированием воды. То есть чем больше у нас будет источников на возобновляемой энергии, тем больше будет у нас зимний провал, потому что зимой у нас солнца меньше, ветра, наверное, тоже меньше, не могу твердо утверждать, но солнца точно меньше. И поэтому, значит, мы должны что-то придумать, чтобы покрыть зимний провал в производстве солнечной энергии. И вот это вот каскад Камбаратинских ГЭС, он может как раз этот провал покрывать за счет того, что он будет зимой активно работать, сливать воду в Токтагул и использовать ее в энергетических целях. Вот примерно как работает наше энергетическое кольцо. Конечно, то, что оно есть, это большое счастье для всех нас. Почему? Потому что Казахстан – это, значит, страна, в которой очень много источников на ископаемом топливе и у которого потенциал огромный для развития. Вот эта вся наша бесплодная степь, она может быть источником солнечной и ветряной энергии. И в то же время Кыргызстан и немножко дальше Таджикистан, вот здесь тоже у них большие мощности, они могут быть регуляторами, резервами для наших солнечных ветряных станций и покрывать нерегулярность графика генерации этих источников. И, конечно, наличие вот этого кольца позволяет использовать все преимущества вот этого наличия природных ресурсов в Кыргызстане, Таджикистане и наших огромных степей для производства возобновляемой чистой энергии. Вот. Ну, в целом, спасибо. У меня все.
Спасибо огромное. Thank you very much, Aset. Thank you indeed also for sticking to time. And last but not least, it's a great pleasure to invite our last speaker of tonight, who is Aynur Sospanova. She is also a mathematician and physicist. So we have ladies with the full mathematic background here today. And she has 12 years of experience in renewable energy system here in Kazakhstan, and among of this 9 years working in the public service. I think that's very important. She was a deputy head of the Department of Renewable, she was head, no, sorry, not deputy, of the Department of Renewable Energies in the Ministry of Energy in Kazakhstan. And and she was at the time working on the concept of transition to green energy of Kazakhstan. And nowadays, she's working as a chairman of board of Renewable Energy Association, Kazakh Green, and also as an expert in the Kazmunay gas. Aynur, floor is yours.
Здравствуйте, меня слышно?
Барбара,
большое хорошо, спасибо. Спасибо, Барбара, за возможность участвовать в тренинге. Я хочу поприветствовать от лица ассоциации ВИА Казах Грин всех участников сегодняшнего тренинга. И поскольку какие-то вещи из моей презентации уже предыдущие уважаемые эксперты уже говорили, я постараюсь очень быстро. Можно перелистнуть на третий слайд, касающийся потенциала возобновляемой энергетики. Вот здесь вот, да. Можно оставить на слайде с потенциалом. Значит, в Казахстане потенциал хорошо изучен, об этом уже Алексей говорил. И если для примера потенциал возобновляемых ветровых станций в Казахстане, потенциал ветровой энергетики в Казахстане, он превышает в 10 раз потребности электроэнергии. Но это не значит, что мы полностью можем перейти на возобновляемую энергетику, но исследование потенциала – это важная часть, и в этой связи климатические сервисы, климатические услуги, которые могут продвинуть развитие возобновляемой энергетики в любой стране, и в частности вот в Казахстане. С этого началось, с исследования потенциала отдельных видов возобновляемой энергетики, началось развитие возобновляемой энергетики. Можно перелистнуть буквально 2-3 слайда. Это вот уже говорили сегодня, атласы по ветру, по солнцу. И на основании исследований, которые проводились до 2009 года, в 2013 году мы смогли сформулировать цели развития возобновляемой энергетики, можно дальше перелистнуть и остановиться на индикаторах. В Казахстане сформулированы индикаторы развития возобновляемой энергетики, и вот здесь вот видно, что в 2025 году у нас стоит цель довести до 6% долю возобновляемой энергетики в общем энергобалансе, довести ее до 30 года до 15%, и в долгосрочном периоде к 50 году доля возобновляемых и экологически чистых низкоуглеродных источников энергии должны, альтернативных так называемых источников, должны приходиться до 50%. Но, как вы знаете, буквально в прошлом году глава государства там озвучил, что Казахстан будет достигать углеродной нейтральности в 2060 году. И это говорит о том, что эти индикаторы, во всяком случае, в долгосрочном периоде до 2050 года этот показатель должен быть больше. Мы в 2020 году ставили цель 3% производства возобновляемой энергетики, и эта цель была достигнута, и поступательное развитие возобновляемой энергетики на текущий момент оно продолжается. Следующий слайд. В Казахстане действует закон о поддержке возобновляемой энергетики с 2009 года, и ряд преференций и ряд норм, поддерживающих инвесторов в возобновляемую энергетику, есть. В частности, можно следующий слайд? В частности, инвестору предоставляется 20-летний PPA-контракт на покупку электроэнергии по тому тарифу, по которому он выигрывает на аукционе. Тариф в казахстанском тенге, причем он индексируется с учетом инфляции и с учетом курса доллара. Единый закупщик электроэнергии от возобновляемой энергетики работает с 2013 года, и сегодня уже все инвесторы в эту институциональную структуру верят, поскольку все обязательства перед инвесторами со стороны единого оффтейкера выполняются. Ну и есть стандартный договор PPA-контракт, стандартный договор на подключение к сетям. Следующий слайд. Ну вот, это текущий момент развития возобновляемой энергетики, и мы видим, что в общем и в целом порядка 2 гигаватт возобновляемых источников энергии в энергосистеме на сегодняшний день работают. Часть проектов находится в процессе строительства и будут вводиться до 2024-2025 годов. Есть уже сложившаяся схема аукционных торгов, которая позволила снизить тарифы на возобновляемую энергетику, и это был тоже позитивный момент. Понятно, что возобновляемая энергетика, она не приносит только благо для энергетики, для системного оператора, это еще и большие вызовы, связанные с неустойчивостью энергосистемы. И вот здесь вот очень важно все-таки понимать, что метеорологические услуги, они должны быть, идти рука об руку с развитием возобновляемой энергетики. Можно следующий слайд. Ну, здесь немножко про аукционный механизм, можно дальше перелистнуть. Ну и, в общем, если говорить про климатические услуги, они должны быть на разных этапах. Первый этап – климатические услуги должны быть на этапе исследования потенциала, тогда, когда разрабатываются атласы. И в Казахстане этот этап, он был проведен в 2009-2014 годах, но этот процесс, он все-таки непрерывный. Второй этап – это уже климатические услуги оказываются отдельным инвестором, отдельным проектом для того, чтобы по тому потенциалу, который есть в Казахстане, выбрать отдельную площадку для реализации проекта, инвестиционного проекта строительства ветровых, солнечных станций, либо гидроэлектростанций. И, наконец, третий этап – это этап операционного сопровождения проекта. Когда уже проект работает, когда уже станция вырабатывает электрическую энергию, необходимо, чтобы исследование ветра, исследование солнечного излучения на данной площадке постоянно проходили, поскольку необходимо точное понимание, какое количество электроэнергии будет выработано в данный конкретный день. Об этом уже до этого Осет говорил, что прогнозирование системного оператора идет за сутки вперед. Конечно, для таких проектов, как ветровые и солнечные проекты, это недостаточно. И необходимо переходить на почасовой график планирования энергосистемы, но за этим, наверное, будет будущее. С этим системный оператор работает. Я здесь не указала четвертый момент. Необходимо также на уровне системного оператора производить прогнозы ветровой и солнечной активности. И, наверное, с все большим проникновением возобновляемой энергетики как на уровне он-грид систем, так и на уровне домохозяйств, каких-то крышных установок. Это прогнозирование на уровне системного оператора должно производиться, иначе энергосистема не будет справляться все с большим проникновением возобновляемой энергетики. Поэтому здесь необходимо понимать, что возобновляемая энергетика без климатических услуг в дальнейшем в Казахстане просто не будет иметь будущего. Спасибо.
Спасибо большое, Айнур. Спасибо. Dear colleagues, thank you very much for very in-depth presentations. I know very well that it was not sufficient time to really present all the knowledge you have brought into this presentation. We are 2 minutes ahead of the deadline, but we may be also able to collect some questions if you would like to. So please ask your question in the chat. I can ask this question to the to our panelists. But at the same time, I'm also aware that probably you are very much overloaded probably at the first day because we are already 3.5 hours here together. And this is going to be the case 6 days. So I hope that you will be able to stay with us until the end of this course, because I believe that you can feel the importance and you can feel the added value of the discussions and the panel sessions which we are offering you. So that's how we go. We want to have you 6 times. It's going to be Monday, Wednesday, Friday, this week and next week, always starting at the same time of Almaty time at 3. And we hope that you'll be actively participating, especially in the training part, where we are going to develop the small proposals. And we are also like in the school checking the participation. So for those of you who are 5 times present here with us, we'll be offering you an international certificate issued by all our partners for the participation in this event with all the topics. I think that that's going to be very valuable. I still don't see questions, but you can save them to tomorrow, to Wednesday. I'm sorry. I see only the previously also and now the comment or the question about the presentations. So the presentations will be available on the website of the conference, and in the meantime you can download them. The recordings is also here, so we will upload everything to the website of the conference. Please feel free to refer to the conference website to find everything else there, and really feel encouraged to ask questions, because I think that we have absolutely great translators, so there is no barrier of the language. Thank you for staying with us. And as a German Kazakh University, we finish at 6:31 tonight, and I would like to encourage you to join us on Wednesday at 3 o'clock, where we will continue with our presentations. Thank you so much to all of the panelists of the all day today, not only to the last session, but to all previous speakers. I think it was very enlightening, and we now more and more understand the links between the climate and the energy system, and the need for quick action. And how do we act? We learn from each other, and this is what we discuss for the Central Asia, to really look into the green future for our region. Thank you very much. I think that without further ado, we can say goodbye for now, and we see each other on Wednesday again. Thank you very much. Have a good evening.
Thank you, Barbara.
Thank you, Jane. Thank you, Ainur. Thank you, Asyet, Alexei, and all the other colleagues of the last session and the previous ones. Thank you very much. Goodbye.